Okay, so if we're factoring x squared minus 36a squared plus 20x plus 100. Again, this is a little different because we have that a in there. So what we're going to do is we're going to group it to start. Okay, so we're going to move that 36 off to the right side for now because we can group anything that has an x or is a constant. So I'm going to group it as x squared plus 20x plus 100 and then minus 36a squared at the end. Because if we look inside those parentheses, can we factor inside the parentheses? Yeah. In this case, it's actually a perfect square trinomial, or you could Sam factor this. Okay, if we're going to Sam factor it, it would be x plus 10 and x plus 10. Or remember, perfect square trinomial, you can take the square root of the first, square root of the third. Square root of x squared is x, square root of 10, 100 is 10. Sine of the second, since that's a plus sign, it's a plus sign, it's that binomial squared. So even if you didn't know it was the perfect square trinomial, you could have Sam factored it, and then if it is the same binomial twice, you do want to write it as that binomial squared. Okay, so either way we do it, x plus 10 quantity squared is that factored for the left side. And then it's minus 36a squared. So now when we look at those two terms, we have something squared minus 36a squared. 36 is what kind of a number? Perfect square. A squared is also a perfect square. And notice this first term is squared. So we actually have difference of squares now also. So I have to factor this one more step further. So remember, in difference of squares, we would take the square root of the first term, and that would be our a. So if I take the square root of x plus 10 quantity squared, what does that equal? X plus 10. So our a in this case is x plus 10. Our b would be the square root of the second term, and the square root of 36a squared is 6a. And then remember, our difference of square formula is a plus b times a minus b. So our a is x plus 10, and then we add to it the b, which is plus 6a. And then again, our a is x plus 10, and our b minus 6a. So answer looks kind of strange because we have three terms inside each of our parentheses, but there's no like terms within that. So therefore, that is correct answer. Again, it's really the sum and difference. We're just taking the square root of each term. One's plus, one's minus. Okay, here's another one. X squared minus 12x plus 36 minus 49y squared. So in this case, we don't have to move anything over because the y squared, the one is already at the end. So I'm just going to kind of put parentheses around my first three terms. That's my grouping. Notice I have a 1 in front, so I have a 1x squared, which is a perfect square. I have a 36, which is a perfect square, so I could do that perfect square trinomial, or you could factor with Sam. I'm going to work on the perfect square trinomial. So I take the square root of the first term, which is x, square root of the second, which is 36, and you use your sign of the middle. Sorry, square root of 36 is 6, not 36. Square root of 36 is 6, and then your sign in the middle, which is negative. And then that's that binomial squared. Again, if you wanted to do SAM, you could have done SAM. It would still be x minus 6 times x minus 6, which is still x minus 6 quantity squared. We then have the minus sign from here, and it's minus 49y squared. And again, what do you notice about each of those terms? Think of this as one full term as being squared, so that's a perfect square. 49 and y squared are perfect squares, so again, we're going to have difference of squares here. If it helps you, you can write the square roots around it and write out what a and b are going to be, or if you can do it in your head, go for it. So the a would be the square root of x minus 6 quantity squared, which is just x minus 6. Your b is the square root of 49y squared, which would be 7y. And then you're doing a plus b times a minus b. So a is x minus 6, and you're doing plus 7y. And then again, your a is x minus 6, and then it would be minus 7y. And again, you don't have any like terms. So you have 3 terms within those parentheses. All right, so for right now, you're working on 85, 87, 89, and 91. We just did 85. All right, so sorry. Then to 87, 89, 91. 87, 89, and 91 are the 3 that you can work on. So for 89, you want to group, I grouped the y's together. No, I wanted to group the x squares together. And then anything else that remained. Okay, because I'm kind of factor this by grouping. Okay, because like there's nothing that's going to factor with like SAM, or there's no perfect square trinomials here. So for 87, for 89, I rewrote this first by putting my x squares together. So it would be x squared y minus 2x squared. That was my first group. And then my second group would be negative 16y and positive 32. That's my second group. From there, I can pull out a GCF from each of those groups. Okay, so my GCF from the first group would be x squared, which would leave me with y minus 2. And my GCF for my second group, remember I always want my leading coefficient to be positive, so I have to pull out a negative, and 16 divides into both of those. And when I divide each of these by negative 16, I get y minus 2 then. So that gives me a y minus 2 as a GCF I can pull out from the whole thing. And I'd be left with then x squared minus 16, which I can then do difference of squares with for the x squared minus 16. So we have y minus 2, x plus 4, and x minus 4. Okay, and I just did difference of squares in that last part. Do you guys need a little bit more time to work on 91 still? All right, I'll give you a couple more minutes to work on page for number 91. Okay, so what do we have to do first for 91? What do they all have in common? They all have an x, so we want to pull that out for sure. And they all have a factor of 2. So you're going to pull out a GCF of 2x first for number 91. So we divide everything by 2x. So that would give us x squared minus 4a squared, the x's are gone, plus 12x and then plus 36. Now you may have some options here because you might look. I did it one way. You may do it a different way. You could do difference of squares here. Maybe pull out a GCF here. I don't know if that's going to work. Normally, if you can factor with a trinomial, you want to do that first. Okay, so I'm going to try and look at this trinomial here, x squared plus 12x plus 36, and put that a at the end. Because now I can FOIL that, or it's a perfect square trinomial, and that would be x plus 6 times x plus 6, or x plus 6 quantity squared. And then you have difference of squares here. So again, you can take the square root of each one, and the square root of x plus 6 quantity squared would be just x plus 6. The square root of 4a squared is 2a. So it would be x plus 6 plus 2a, and x plus 6 minus 2a. Are problems where we have these fractional exponents. Okay. So we can think of, you can write those two problems down a while, x to the 3/4 minus x to the 1/4. And so think of it this way. If I had x to the third plus 6x to the 7th, what's my GCF for that one? X to the third. It's your lowest power of x, right? Your GCF is the lowest power of x. So even though these are fractional exponents, they both have x's in them, and my GCF is going to be the lowest power of that. So what is smaller, 3/4 or 1/4? 1/4, right? So here I'm going to pull out an x to the 1/4 power. And guess what we divide by then? X to the 1/4. Remember, what do I do with my exponents when I'm dividing like bases? What am I going to do with the 3/4 and the 1/4? What operation? I had x to the 5th over x to the 2nd. What do I do with those? We subtract them, right? So guess what I'm going to do with 3/4 and 1/4? Subtract it. So I have to do 3/4 minus 1/4, which would be 2/4 or 1/2. So here I'd get x to the 1/2. And then what's x to the 1/4 over x to the 1/4? Just 1. And we are finished then. We do want to make sure our exponents are always positive, okay? But we do have positive exponents there. If we look at 96, again, we're pulling out our lowest power of x. So what is smaller, negative 3/4 or positive 1/4? Negative 3/4 is smaller. So I need to pull out a GCF of x to the negative 3/4. And what number divides into 12 and 6? 6. So I'm going to divide everything by 6, x to the negative 3/4. So we have 12 divided by 6 is 2. What is negative 3/4, x to the negative 3/4 over x to the negative 3/4? That would equal 1 because it's going to cancel out. It's the same on the top as the bottom. So that first term just becomes 2. What happens to my 6's here? They cancel out. And then I'm going to have x to the 1/4 over x to the negative 3/4. So I'm going to subtract those exponents. So be careful here. It's 1/4 minus a negative 3/4. The double negative would make it positive. So I'm really doing 1/4 plus 3/4, which would be 4/4, which is just 1. So that would be x to the first power. Remember, the base is still x. So x to the first. Now, the only thing we want to finish up or tidy up is, remember, we can't leave negative exponents. So the 6 really has a positive 1 as the exponent, so that can stay up top. This parentheses of 2 plus x has a positive exponent really on the end. And so the base of x that has that negative exponent is just going to move to the bottom. So I have x to the positive 3/4 on the bottom. All right, and then we have one last problem to try. X times the quantity of x minus 1 to the negative 1/2 plus x minus 1 to the positive 1/2. So this is kind of like a factor by grouping almost. So they both have x minus 1s to the 1/2 as the base, right? Which is the smaller exponent? Negative 1/2 or positive 1/2? Negative 1/2. So I have to pull out x minus 1 to the negative 1/2 power. And that means I'm going to divide each of my terms by x minus 1 to the negative 1/2 power. So within my first term, the x minus 1s to the negative 1/2 would cancel out, and I'd be left with just x. And on my second, I have the same bases. So again, that means I'm going to have to subtract my exponent. So it's 1/2 minus the negative 1/2, which I'm really adding those together. So I get 1 whole again, 2 halves or 1. So again, this would now be plus x minus 1. The base is still x minus 1 to the first. Now we can clean that up a little bit. Since they're adding these, do we really need the parentheses? No. And so we really get x plus x minus 1. And we have x minus 1 to the negative 1/2 still. So I can't leave a negative exponent, so that base has to go to the bottom. So I'd have x plus 1 to the 1/2 on the bottom now. And then inside my parentheses, what's x plus x? 2x. And then minus 1. So I would recommend tonight just trying like 93, 95, 97 maybe. Try doing three of those. We already did the first part of the homework listed up there. If you do 93, 95, 97, you're in good shape. Also, if you didn't do any of the other homework over the week, I would say definitely get that practice in, okay? Because again, you have a quiz on Monday on all the factoring. You really want to be pretty sharp on that.